This will be section 3.2. We're going to be finishing up all the mathematical calculations that we did throughout the last year in chemistry and a little bit of review. And what that is going to entail here is empirical formulas, a little bit of stoichiometry, and a little bit of limiting and excess reactants. So first things first, let's try and figure out how to review and how to solve for an empirical formula. So when we go ahead and solve the empirical formula, remember the general process is they're going to tell you the percent of each compound or the weight of that compound, and you're going to assume you have a 100-gram sample. So you're going to go from percent to grams, assuming you have a 100% sample. Then you're going to go from grams to moles of each element. Then you're going to divide by the smallest amount of moles of your element, and that is going to give you a whole number ratio. So if we look at a problem, the compound para-aminobenzoic acid, you may have seen it listed as PABA on your bottle of sunscreen, is composed of carbon 61%, hydrogen 5%, nitrogen 10%, oxygen 23%. Find the empirical formula of PABA. You have been given the percents. Now what you're going to do is you're going to take those percents, you're going to assume you have a 100-gram sample, and you're going to convert those to grams. So we have 61.31 grams for 5.41 grams, 10 grams of nitrogen, 23 grams of oxygen. Then you're going to convert each unit into moles. So we're going to divide by 12.01 for carbon, 1.01 for hydrogen, and the molecular weights of nitrogen and oxygen as well to convert to moles. So you're going to have moles. Once you have moles, you're going to divide by the smallest amount of moles. Well, that ended up being the 0.7288 moles of nitrogen, so we're going to divide by 0.7288. And when we do that, we get 7 for carbon, 7 for hydrogen, 1 for nitrogen, and 2 for oxygen. Remember, in this process, if you had 1.5, you would have to go ahead and multiply each one of these by 2, if you can remember that from last year as well. But with everything said and done, we have 7 carbon, 7 hydrogen, 1 nitrogen, and 2 oxygens, and our formula is going to look like this. That is our empirical formula. That is not our molecular formula. It's possible that I may say the molecular formula weighs 400 grams. The empirical formula, let's just say hypothetically, this weighs 200. So then you would have to go 400 divided by 200, which is 2. And you would have to take this whole compound by 2. And your molecular formula might be C14H14 N2O4. Just a reference point as to a couple of things that we did last year that we can review. A lot of times combustion, when we're doing combustion compounds, we're dealing with figuring out carbon dioxide and water. We don't need to worry about that. Stoichiometry, when we talk about doing stoichiometry calculations, remember, we have to have a balanced equation using coefficients. So we have to have a balanced equation using coefficients. One thing that you'll want to note, remember, when we're going from one substance to another, we can't go straight grams to grams. We have to use molar masses. So when we do that, we're going to go from grams of A to moles of A to moles of B, then to grams of B. And in between, it kind of shows you the 3-step railroad track process that you have to use for that. When you go from grams to moles, you're going to use the molar mass of A. When you go from moles of A to moles of B, you're going to use the molar ratio, which is just the numbers out in front of each substance, the coefficients out in front of each substance. And when you go from moles of B to grams of B, you're going to use the molar mass of B. So a little stoichiometry review. So if you were to get a problem like this, we take a simple, you're starting with 1 gram of C6H12O6, and we calculate the moles. We want to figure out how many grams of water or carbon dioxide that will produce. Remember, there is no direct calculation going from grams to grams. So you're going to have to go from grams of A to moles of A to moles of B to grams of B. So something that you'll want to keep in mind, just refresher when you're doing a stoichiometry problem. If you have to figure out limiting reactants, Remember, limiting reactants kind of work backwards, and the limiting reactant, the math problem works backwards. The limiting reactant is really what's limits the product formed in the reaction. So before the reaction here, we have 10 hydrogens and 7 oxygens. After the reaction, we get 10 waters and 2 leftover oxygens. That means the limiting reactant was hydrogen. The excess reactant is oxygen. So remember limiting reactant and excess reactant and how to kind of solve for each one. Remember, you're just doing the railroad track backwards. So you're going to figure out the maximum amount of one substance that can be formed in a reaction. Then you're going to work backwards to the excess reactant to find out how much you actually use, because you know you're going to have some in excess. Last couple things when we're talking about math, we have theoretical yield versus percent, or we have theoretical yield and percent yield. Kind of how do those two combine together? Theoretical yield is in the mathematical calculation how much you should have. So theoretical yield is how much you should have mathematically on paper. Your actual yield is going to be how much you actually make when you run the experiment in lab. So the actual is going to be what you run in lab. The theoretical is going to be the math part. So if you want to kind of take the lab part divided by the math part, and that's going to get you your percent. Now you want to be as close to 100% as possible. However, not all chemical equations work out to 100% yield all the time. You have variables that are going to affect your reaction as you go through things. So that is kind of a rundown of the 3.2 math. We have limiting reactants, we have stoichiometry, and we have empirical formula, all kind of review from last year. So you're going to have a couple problems on your quiz with that, and you have questions, you can let me know.